Hi folks, we're going to be looking at the concept of integration with substitution. So this is using integration on composite functions. So the big picture concept is that this is the reverse of the chain rule in derivations. So when you're doing derivatives, if you did the chain rule, this is kind of the reverse of that, so to speak. And so we're going to start by writing the chain rule and then integrating. So this is the chain rule, right? The derivative of f of g of x is equal to the derivative of f of x, with g of x still plugged in, times g prime of x. And now I'm going to take the integral of both sides. So we're just going to slap an integration onto here. Integrating the left side is pretty easy because it's the integral of a derivative, so it's just going to be f of g of x plus c. And then that's going to equal on the right side the integral of f prime of g of x, g prime of x dx. And we're not going to mess with that at all because this ends up being something kind of useful to work with. If you want to see it in a more kind of clear form, we'd say f of g of x plus c, oops, is equal to the integral of f of g of x times g prime of x dx. In other words, if you have a function times a composite function times the derivative of the composite piece, then the antiderivative, or the integral, is just the antiderivative of the outer piece with the inner piece left in place. More commonly, do I have it written in here? I do not. More commonly, you'll see it written like this, where we write u equals g of x, and v equals, that's not right. Sorry, I need to clean that up. More commonly, you'll see it in this form of f of g of x is times g prime of x dx is equal to f of g of x plus c. So like I said, I wrote that down below, but I wanted to clean it up here a bit at the top. And this is something that, kind of like the chain rule, you learn best through practice. So I'll do a quick example, and then there'll be a couple other videos with a lot more examples. So start by looking for a nested u of x to take the derivative of it. So for example, in this case, I see that there's a function in here that's nested within. So I'm going to call this my u, is u equals 1 plus 2x cubed, because I saw it was nested in this x to the 5th function. So if I take the derivative of that, I get du by dx, and that's going to be 0 plus 6x squared. And now I want to substitute things in. And I'm going to have problems because now I'm going to be, if I just substitute in, I get I get x squared times u to the 5th. And then normally I'd still have the dx here, and I've got an x here, and I can't work with multiple variables. So instead what we're going to do is we're going to solve for this dx so we can substitute in an equivalent version. So what that ends up giving me is dx is equal to du divided by 6x squared. So just by algebraically manipulating flip-flop back and forth. And that gives me over here du over 6x squared. And you'll notice that means the x squareds cancel, and I end up with the integral of u to the 5th du. That's pretty easy to solve. That's just going to be 1/6 u to the 6th plus c, but we know that u is what we had up there. So 1/6 times 1 plus 2x cubed to the 6th plus c. So that's our result. If you take the derivative of this, you get 6. The 6 and the 6 cancel, and I get x to the 1 plus 2x cubed to the 5th. And then the derivative, I made a mistake in here somewhere. Where did I do that? Oh, there should be another 1/6 here. So this should be 1/36. So the 6 will cancel with the 1/36 and give me 1/6. And then when I take the derivative here for the chain rule, I'll get the extra x squared out. So to recap this real briefly, and then we'll have some more examples. If you think you might be using u substitution, the only way to know is just to try it and see if it works. And what you'll want to do is find a piece, like I said here, this 1 plus 2x cubed, and then just start working it out. U equals 1 plus 2x cubed, du by dx is whatever the derivative is, solve for dx, plug things in. And if you end up getting something that's u du and there's no x's, great, work it through and find your result. As time goes on, you'll get a better eye for which functions you can use substitution on, and it'll be less of a guess and more of a confident kind of first step. But what you can take, this can be repeated, you can do it multiple times, and that's what we'll look at in some of the later videos.